these organized a little bit so they're a little more squared away. Okay, so today is August 19th. And we're taking a look at section P-2. All right, now what this one is basically your laws of exponents. All right, that's the main part of what this review section is. All right, there's a little bit of scientific notation thrown in there, but for the most part, it's laws of exponents. Okay, now on some of the laws of exponents, I kind of do my own thing. All right, so I may do it differently than what you originally were taught. However, so it doesn't make any difference. All right, you can use the traditional laws of exponents that you know how to work. All right, or if you like the way I do it a little bit better, then you can use my method. Okay, some main points. We're just going to go through, take these laws of exponents and do main points. Okay, so the first one is when you get done with your final answer, you don't want to have any negatives. All right, so no negative exponents. That's one of the ways you're going to know that you are done. You want to make sure you have no negative exponents in any type of problem. Okay, so some things that you can do. Now, there is an actual rule for this. However, an easy way to look at this, let's say I had x to the negative 4 over y to the negative 3. All right, I've got negative exponent in the top, I've got negative exponent in the bottom. I can't have negative exponents, they're not allowed. Okay, so they're basically, the rule that you are taught is a 1 over x to the n rule, but basically what that's saying is you can take a base with a negative exponent that's in the top and move it to the bottom and make it positive. You can do the same thing going the other direction. If you've got a base with a negative exponent in the denominator, you can move it to the top and make it positive. So in this case, I'm just going to switch the locations. I'm going to put the y to the 3rd at the top, make it positive. I'm going to take the x to the 4th and put it in the bottom, make it positive. Okay, now what you can't tell from this is, let's say that there's a 1 coefficient right there, right in the numerator, coefficient in front right there. There is also another 1 coefficient right there in the denominator. Now what you don't see is those coefficients did not move. So the green coefficient is still on the bottom and the red coefficient one is still on the top. Okay, so in other words, if this was a 2 and a 3, the 2 would stay on the top, the 3 would stay in the bottom. The coefficient does not move. All right, the only thing that moves is the base and the exponent, and the exponent is the only thing you change the sign on. Okay, and then more along the lines of the way you were taught, the rule per se is like x to the negative 2. All right, and you were taught that is equal to, just by a basic rule, 1 over x squared. Okay, that was the rule in laws of exponents in Algebra 2 that you were taught. All right, but taking my rule of, okay, I just want to switch locations and make it positive. This is not a fraction, all right? X to the negative 2 is not a fraction, but I can turn it into a fraction. I can say that's x raised to the negative 2, right? Put it over 1. The coefficient 1 there is still going to stay in the top. All right, so that 1 stays in the top. And then the base and the exponent gets moved to the bottom and becomes positive. All right, so my rule of moving it to the opposite location to make it positive works with the traditional rule you were taught on how to get rid of your negative exponents. Okay, so another thing, all right, there is a 0 rule. All right, any number raised to the 0 power is 1, right, by definition. So if I had an x to the 0 power, it equals 1. If I had, I don't know, 24 raised to the 0 power, it's 1. All right, so basically when you see these, anything raised to the 0 power in the problems, you're just going to be able to cross them off, okay, because it's a 1 and multiplying by 1 doesn't change anything. So I don't know, as a little example of that, I don't know, if I had something like a 2x to the 0, y to the 4th, and I was going to put this over a z squared, all right, and it said simplify it. All right, well, I don't have any like bases, like no negative exponents that I have to get rid of, but there is an x to the 0 power. All right, well, that really means 1. And then in that numerator, 2 times 1 times y to the 4th, you know, doesn't change anything. So basically, anytime you see that x to the 0 power, you can get rid of it, cross it out, b squared. Okay, so that's a good way to look at it. All right, another rule called the product rule. All right, and this one is when multiplying like bases. What do we do to the exponents? Anybody remember? Add them. When multiplying like bases, add the exponents. Okay, so it's a pretty straightforward one. We'll do just one little example because I do think this one's kind of easy. All right, let's go ahead and throw like a negative 2x to the 5th in there. Maybe we're multiplying that by a 3, x to the 7th, and then a y squared. Okay, I'm just multiplying two terms on this one. The coefficients, you just multiply like normal. You do not apply the rule or anything. So a negative 2 times the 3 is going to give me a negative 6 there. I'm going to go through and I'm going to find those like bases and add the exponents. So that's going to be an x to the 12th. There is no like base. I just got a y to the 2nd there, so I have to include that into my answer. Okay, so hopefully that one, straightforward rule, and you kind of remember that. Okay, so far so good. Okay. Now we've got, I think, I'll save the one that I do differently for the last. Okay, so we've got power raised to a power. Okay, a power raised to a power. Okay, power raised to a power. So that's exactly what it's going to look like. I'm going to have a base, maybe say an x. I'm going to raise that to a power. Okay, but then that is going to be raised to another power. Okay, so x to the 3rd raised to the 2nd power. All right, so when you got a power raised to a power, what do you do to those exponents? You multiply them. So this is just a straight x to the 6th. All right, now again, in that type of example, you don't really see what's happening to the coefficient. What is a 1 raised to the 2nd power? It's still 1, right? And so you can't see that anything is happening to that. Let's put a coefficient in front. Let's keep the numbers small so we can do this in our head really easy. So let's do a 3x to the 4th and then to the 2nd power. Okay, now, obviously for the x to the 4th, we're going to take 4 times 2 and get 8. So I know I got to multiply those two little exponents. The coefficient, all right, has an imaginary 1 exponent. All numbers have an imaginary 1 exponent on them. So if it says power raised to a power, I got to multiply the exponents. Technically, I've got to take 2 times that 1 exponent that's right there. 2 times 1 is 2. So the line that a lot of people don't write down and then which creates the problem is really you've got a 3 to the 2nd power. X to the 4 times 2 is going to be 8 right there, which means now I've got to take that coefficient and square it. 3 squared is 9. Okay, I see a lot of people try to do 3 times 2 on the coefficient and they put a 6 right there, or they just ignore it altogether and write 3x to the 8th. But that power raised to a power has to be done to every exponent that is on that inside of there. All right, so like it's obvious when you've just got a bunch of letters. So if I had, say, an A to the 2nd, a B to the 4th, and a C to the 5th, and I'm raising that to the 3rd power, all right, the power raised to a power, you do it to every exponent on the inside. Okay, every exponent. So then that's going to be a what? An A to the 2 times 3 is 6. B, 4 times 3 is going to give you a 12. That C, 5 times 3 is going to give you a 15. So you can apply that rule over and over and over multiple times. Okay. All right, so good okay on power and power. Power and power. Okay, let's try the one that I kind of adjust differently than the way you were originally taught. All right, the last one I want to do is a quotient rule. Okay, now, the rule you were probably taught, which is in most textbooks, is when dividing like bases, what do you do to the exponents? Oh, it's got to be louder. Subtract. You subtract the exponents. And there's absolutely positively nothing wrong with that. Okay, you did that in Algebra 2 when you solved division, you went ahead and you subtracted those exponents. Okay, but sometimes if you subtract, like top to bottom, you subtract like normal, what happens is then you end up with a negative exponent. Okay, but then we've got a rule that says, oh, wait, you can't have negative exponents. So then you have to apply another rule to get rid of the negative. All right, so it almost causes a two-step process. Okay, so I come up with a way to eliminate the negatives when you are dividing. So then you only have one step. Okay, so this is my rule. All right, my rule says that we are going to subtract. All right, and basically subtract just like normal. Okay, like 8 minus 5, 7 minus 3, whatever it is. We're going to subtract and put, and right now I'm just going to use the word it because when I demonstrate some examples, you'll get this. We're going to subtract and put it where the largest exponent is. And like I said, right this second, that may not make sense, okay, but it will in a minute. Let's do one that fits the top rule better than this one necessarily, or something you would have done early on before I gave you my rule. Let's say you had a 10 x to the 8th over a 2 x to the 5th. All right, so if you did not know my rule and you were just doing what you had learned in Algebra 2, you would take those like bases, you're dividing them, you would subtract, you get an x to the 3rd, right? And then you would take the coefficients in front and you would divide. So 10 divided by 2, that's going to give you a 5. So you would have a 5x to the 3rd. Okay? Now, my rule, let's write it again. 10x to the 8th, 2x to the 5th. Okay, so leaving it as a fraction like that, you can reduce this like lowest terms like you would, right? 2 goes in 2 ones, 2 goes in there 5, all right? 10 divided by 2 is 5, same thing here. My rule says subtract, so 8 minus 5 is 3, and then put it where the highest exponent is. Well, x to the 8th, that exponent is higher than x to the 5th, so my x to the 3rd goes in the top, so 5x to the 3rd, and then technically this 1 is over here, but these two things are equivalent, right? So we just write 5x to the 3rd. So on this one, my rule doesn't necessarily help, all right? But if we do something like this, let's say we do a 14, and let's make it a little bit more complicated, more letters here. Let's do an x squared, a y to the 8th, and then let's put a 20 down here. Let's go x to the 7th, and then y to the 4th. Okay? So I generally treat these coefficients like a fraction. That would be like 14 over 20. I can reduce the lowest terms, right? I can take 7 into both of them, so or I can take 2 into both of them, rather. So 2 into this gives me a 7, 2 into this gives me 10. So I know my leading coefficients are going to be 7/10. All right, now apply my rule to that right there. All right, I'm going to subtract just like normal. 7 take away 2 is 5. All right, so I'm going to have an x to the 5th, but where am I going to put it? I'm going to put it in the bottom because x to the 7th is bigger, so I'm going to have an x to the 5th. All right, now apply the rule to the y's. Subtract like normal. 8 take away 4 is 4. the exponent that is higher is in the top, so then my y to the fourth goes up there. All right, it's quicker in the sense that because had you used this rule up here, you would have subtracted this. 2 take away 7 would have given you -5. It would have been in the top, then you would have had to move it to the bottom. All right, doing it this way, subtracting like normal and putting it in the bottom kind of saves a step. Okay. Now, so far, all of these have been positive exponents. All right, there's nothing that says I can't have negative exponents to start with. Okay, so let's do an example with that. Okay, let's suppose I had, I don't know, let's try 3x squared y to the 5th, z to the -3rd, 5x y squared z to the 4th. Do my leading coefficients have to be reduced on this one? They don't, right? 3/5, 3/5. I don't have to do anything with that. I'm dividing some like bases, so I know I've got a 3 here. I know I've got a 5 here. All right, I'm going to deal with my x's. Imaginary 1 right there, so I'm going to have an x to the first power. Where's it going to go? In the top. So an x to the first, or x. I don't need to write the 1. All right, I'm going to take a look at the y's. I'm going to subtract like normal. So 5 take away 2 is 3. It's going to go in the top because that's the highest exponent. So I'll have a y to the 3rd in the top. All right, now I don't want to try to subtract these right here because I got the -3. All right, so yes, this is a quotient right here, but one of them's got a negative exponent. If I take the z to the -3rd and move it to the bottom and make it positive, I'm going to be multiplying z to the 3rd, right? So it's no longer there in top. I'm going to move it to the bottom and make it positive first. So really, with the z's, I'm not going to do quotient rule. I'm going to do when multiplying like bases, add the exponents. So then I'm going to have a z to the 7th in the bottom. Okay. So you can do a lot of work, like you can go from here to the answer. All right, I usually mark up the problem and everything. All right, but you can pretty much do these in one step until it gets complicated, until they get really complicated. All right, let's do one that seems to give people problems. We'll do one more of these before we do some practice. Let's suppose I had 6x to the 3rd all raised to the -2. All right, different people are going to work this differently because different people are going to see things first. All right, some people are going to see a -2 and go, oh my God, I got to get rid of my negatives. All right, other people are going to look at this and go, oh wait, I've got power raised to a power. All right, the order in which you do that really doesn't matter as long as you don't make a mistake in your steps. All right, let's do power raised to a power first, and then I'll work it out the other way as well. All right, so if I'm doing power raised to a power, I've got to take that -2 times the 3. There's an imaginary 1 on the 6. Can't forget about that. So you're going to take the -2 times the 6. Okay, so at that point, I'm going to go ahead and work this down, I think. I'm going to have a 6 to the -2, x raised to the -6. Okay, am I allowed to have negative exponents? Not allowed to have negative exponents. All right, it's not a fraction, but technically it is because if I put it over 1, it would be in the numerator, right? So I move the base and the exponent to the bottom, and I make the exponents positive. So both of those are going to get moved to the bottom. Now, when I move them to the bottom, that means I'll have a 6 to the 2nd power, because make that exponent positive, I'll have an x to the 6th. What's left in the numerator? Yeah, 1, right? Because technically there's an imaginary 1 that's sitting right there. I can multiply anything by 1. It doesn't change anything. So I've got that. And then can I go ahead and multiply this out and get 36? 36x to the 6th. Okay, now that's one way to do it. Power raised to a power. But if I had 6x to the 3rd raised to the -2, could I get rid of the negative first. If I wanted to get rid of the negative first, I could. This entire thing is the base. It's being raised to a -2, to the power of -2. Again, it's over 1 with an imaginary 1 being multiplied there in front. So I can move this entire base to the bottom and make this positive. So then I would have a 1 over 6x to the third raised to the second power. And then now you still have power raised to a power. You got to do some simplifying. So see, I'm just doing them in a different order. I'm still going to end up with the exact same thing. I'm going to have a 1 over a 6 squared x to the 6, and then I'll multiply that out and get the 36. So the order in which you do it, as long as you don't make any mistakes, is going to be fine. Okay, so far so good? All right, now what I want to do is I want to give you 3 problems. All right, just for a little in-class practice. 3 problems shouldn't take you very long, so we'll go ahead and do this. Okay, labeling an in-class practice in your notes will know that you did it without me working it out. So as soon as I write them down, you can start working on them. Then I'm going to pause and give you a few minutes to try those. If we weren't in the middle of a pandemic, I probably would have been walking around the room watching you do this. All right. And or I probably would have, as you people would have begun to get them done, I probably would have sent people to the board to put up what they had just done so that everybody else could see the work. All right. However, we'll just adjust the way we're doing this a little bit. Okay. Main thing was I just wanted to see if you could practice like on your own. And then some of you, I could tell, did this pretty quickly because your pencils start writing. All right. So it is review. So that means you got a hang of it. Others of you work a little bit slower, and that's okay too. All right. So on this one, you should have gotten a 9x to the 4th, y to the 10th. On this one, you should have gotten a -5 in the top with an x to the 11th, a y to the 4th, and then a b to the 3rd in the bottom. And then on this one, you should have gotten a 20 x squared y to the 5th. Okay, so if you were close, all right. If not, you could write the right answer down and then try to go back and figure out why you didn't get it. Okay, and obviously we can ask some questions during during work time today. All right, now the whole point, like I said, in this, like I said yesterday, this pre-calc book puts multiple things in one section. All right, the P chapter is supposed to be review. All right, now if you stop and think about what you did in Algebra 2, everything we did in today was done in an entire chapter in Algebra 2. All right, it was like learn 1 or 2 rules at a time in each section. All right, and in this section, it was the entire thing all together. So we did an entire Algebra 2 chapter, all right, in one section because it is assumed to be a review. Okay, so they're speeding up. Now, these laws of exponents can easily be applied to scientific notation. Okay, so for that reason, all right, they're going to put that in this section as well. So we're going to take a look at some scientific notation. I am going to assume that just your basic scientific notation, you know how to do. You do that a lot in a chemistry class. All right, the whole purpose of scientific notation is what? To take really large numbers and write them so that they're in a condensed form, or to take really, really small numbers and put them in a condensed form. You don't want to have to write a string of zeros out, that sort of thing. All right, in your homework, I think you're going to see some multiplying and dividing with scientific notation. All right, you do, yes, there is an EE button or a scientific notation button on your calculator, and if you had chemistry, you might have learned how to use that button. All right, however, you can real quickly do this without a calculator, even though they're going to be really, really large numbers. Okay, so if I had something like 6.1 times 10 to the 5th, I'm multiplying that by 4 times 10 to the negative 9. Okay, both those numbers are in scientific notation. I'm going to want to multiply them, preferably without a calculator. And I'm going to want to make sure my answer is in scientific notation when I get done. Okay, so hopefully most of you could take those two numbers that are out in front and multiply those in your head because they're not too bad. 6.1 times 4, what that's going to like 24.4. Okay, hopefully we can do that kind of quickly in our head. Okay, now you just learned when multiplying like bases, add the exponents. All right, well, there I've got a 10 to the 5th. Here I've got a 10 to the negative 9. So I have like bases, right? The base is 10. So when multiplying like bases, I add the exponents. I keep the base the same, so 10 to the negative 4. All right, so I didn't need a calculator. Now, is this in scientific notation? It's not in scientific notation because you've got two numbers right here to the left of that decimal, right? So, shortcut, I need the decimal here, so I'm going to hop at one hop to the left. When I do one hop to the left, what do I need to do to this exponent? Add or subtract 1? Or do we know? We might not have done this last year in chemistry. Camden, do you know? Yeah, did you say add? Yeah, I thought you did. Okay, so I'm going to add 1. If I hop one hop to the left, I'm going to add 1. If I do 2 hops to the left, I would add 2. If I did 3 hops, I'd add 3. All right, so the scientific notation answer for this is 2.44 times 10 to the negative 3. Okay, let's put down here, if I were to hop to the right, then obviously if I hop to the left and I added 1, when I hop to the right, I would subtract 1. Okay, or 2, or 3, or 4. Okay, so that's using the rule of when multiplying like bases, we add the exponents. Okay, now as another example, there is going to be one with a quotient, probably. So 1.8 times 10 to the 4th, and then maybe divided by, say, 3 times 10 to the negative 2. All right, so again, hopefully these numbers that are sitting here in front are going to be something that you can pretty easily just go ahead and divide 1.8 divided by 3 in your head. All right, with like 0.6. Okay, we can get 0.6 there pretty easily. Okay, I know I'm going to have a time sign. Now, my shortcut rule on dividing like bases here is not going to work. You cannot take that -2 and move it to the top. All right, this one you have to do the rule you learned in Algebra 2, which when dividing like bases, you subtract those exponents and you subtract them in that order, top to bottom. So this would be like a 10 raised to the 4 minus a -2. Well, 4 minus a -2 really gets you a 10 to the 6th, okay? So that's the honest rule that you've got to do with the quotient there. All right, then you're going to come down here and you're going to look at this. Is this in scientific notation? It's not, because when you've got a leading 0 in front, that doesn't really count as a number. All right, which means I've got to hop 1 to the right. When we said hop 1 to the right, we're subtracting 1. So in scientific notation, 6 times 10 to the 5th. Okay. These type of math problems really seriously can be done probably quicker by hand if you know the rules than taking the time to plug it into your calculator. If you took chemistry, all right, how many people took chemistry last year? Did they show you how to use the little EE button? I was going to say, because Mrs. Koss used to before she retired, but I didn't know if like the new people were doing it. All right, so obviously you're more than welcome to, if you've got the calculator, you can more than welcome to do it. But SAT, if you're taking that one more time your senior year, okay, doing this by hand, it might be faster because you're trying to answer those quickly. All right, so I think that covers just about everything in section P-2. All right, if anybody's got any questions, I haven't heard from you guys at home. All right, obviously all you have to do is unmic yourself and say, hey, I got a question. All right, same thing with you guys. Raise your hand, you got questions, but hopefully going through this P chapter, it's all going to be review. It's just kind of slow pace getting into this. All right, you've got the rest of the period to work on a book assignment, okay? And for those of you that were at home, thanks for joining us. All right, and I think I'm going to close the meeting if no one's got any questions. And no one said anything, so see you guys later.